Hey Brady. All right, you were wondering about cosine, 5 pi over 3. Fun stuff, trigonometry. So, trigonometry is really important, especially when you're talking about waves, anything that happens in a cycle. Your refrigerator turns on and off to keep things cool. Your thermostat goes a little bit hotter than you want, and then a little bit colder than you want. Anytime you have these cycles, we're talking about trigonometry. I think I can. Well, I'm going to leave my face here for now. It's fine. This is a basic GIF of I don't know about there of what's going on with sine and cosine. I just Google searched unit circle GIF, and this is what came up. The idea is that as this point goes around a circle, it goes back and forth, side to side. So here it starts at 1, goes to 0, goes to -1, and then it goes back to 0, and it goes to 1, and back and forth and back and forth. And that's the cosine function. So you can see the point going up to 1, and then to 0, and then to -1, and then back to 0. Sine works the same way, except sine is the y-axis. It's the y value. And so sine is going to be going up and down. It's going to go to, okay, so we'll go all the way around the circle. Here we go. 0, and then up to 1, and then back down to 0, and then down to -1, and so on, back and forth. So that's where we get this sine function from, is the up and down. Cosine is x, sine is y. When you're trying to find radians then, we're asking how far around the circle is it? So pi radians is halfway around the circle. 2 pi radians is all the way around the circle. Your question of 5/3 pi, 5 pi over 3 is almost all the way around the circle. 6 pi over 3 would be a full rotation. That'd be 2 pi. So cosine of 6 pi, or 6 pi over 3, cosine of 2 pi, would be 1, because cosine is the x value, and it would be back at the beginning. Cosine of 3 pi over 3 would be -1, and then 6 pi over 3. If you search unit circle, if you just do a Google search of unit circle, there are tons of these images out there, and this is your sine and cosine. Cosine is always x, because that tells us the x value. So cosine is 1, and then as we go around the circle, the x value on all these points of all these coordinates is the cosine. So here's your answer right there. 5 pi over 3, 5/3 pi. The x value is 1/2. You can get this by doing the Pythagorean theorem. All these numbers that you're seeing here, you get from the Pythagorean theorem. So I'm going to draw something here in just a second. I know that you can't see what I'm drawing yet, but we'll get there. There we go. And here we are. So here's my unit circle right there. This point that I've made is 5 pi over 3. This radius right there is always 1 in the unit circle. I drew this line just because it's in the bottom, the fourth quadrant over here. If you think about a graph. So it's over here. So this radius is 1, and the angle that ends up being created here is going to be 30 degrees. But you can't really see that too well. But the idea is you could work out exactly how long this leg of the right triangle is by using some different arithmetic and some different work. But that's where this number comes from, is where we've got this right triangle here. We know, if we know what the angle is, we can work with this right triangle and figure out the x part of it, this leg along the x-axis. The other way, and this is the way I did it when your dad just texted me, is I just memorized a really nice feature of this. If you look at the cosines, they go, the numerators, the top of these fractions, go 3, 2, 1, 0. And they count up. 1, 2, 3. And then we get to -1. I guess you have to memorize that piece. 3, 2, 1, 0, 1, 2, 3. So if you know that pattern, then you can just go around and say, okay, well, let's see, 1/3 pi, 2/3 pi, 3/3 pi is halfway around, 4/3 pi, 5/3 pi. Okay, if I know where it is in this pattern, then I can just go 3, 2, 1, 0, 1. Oh, 1/2. And they're all over 2. Root 2 over 2, root 3 over 2. Root 1 over 2, square root of 1 is 1. So that pattern follows. And it works for sine too. Sine goes 0, 1, 2, 3. 1. 3, 2, 1, 0. So sine and cosine both count in that way. So if you can memorize that, or if you just have this unit circle, if you can have notes, then there it is. But that's how I calculated it. Is I just went around the unit circle and found that point. You'd also have to do some, or you could do some Pythagorean theorem and work it out from there. If you need to show the work on the Pythagorean theorem, let me know, and I can follow up with you and do some more. But this is what's going on with sine and cosine when you're dealing with a circle, and this is where those numbers come from. Okay, hopefully that helps. Let me know if you need more information and more detail, or if you have follow-up questions.